Good afternoon, everyone. I'm really glad to be here. And it's a nice coincidence because this talk is a bit related to a talk of another speaker in the other room about revolutionary architecture. So it's a nice thing. This talk is about, first, let me say that I'm a software engineer at Chubb. For you that don't know, Chubb is a global provider of insurance products. So from casualty, property, health, whatever you can think of. And today's talk is about legacy systems. They are the backbone of most enterprises, and very often they make us cry, as my colleagues in the crowd know. They are critical, costly, and incredibly difficult to replace. If you've ever worked with them, you already know that, and if you haven't, for the younger amongst you, this day will come for sure, so buckle up. Today, we're diving into the beautiful and very often terrifying world of legacy systems and software modernization. Here is what I'll cover in the next 15 minutes. First, a few words about legacy systems, what they are and why we love to hate them. Then some modernization hits, which are supposed to work as your guideline to modernization without turning your entire IT department into zombies and losing your sanity. And then lastly, some patterns of legacy displacement, which have been proved to work in the real world. So let's start. It's estimated that 30 to 40% of an organization's technology is legacy, and it consumes more or less 80% of an organization budget. So chances are that you're going to end up working in such a project sooner or later. So if legacy is going to be a part of your career, and statistically it will be, you might as well learn to work with it effectively. Because here is the truth. Legacy is where the real money is at. It's where the core business logic lives, and where you will learn more about software architecture than in any greenfield project will ever teach you. Furthermore, AI might make some of our jobs obsolete in the next years, but good luck using it to make sense of thousands of lines of stored procedures in ancient databases. So let's ask ourselves, what makes a system legacy? So in my opinion, it's basically three things. First, fear-driven development. We have all heard stories of components that somebody changed in 2020 and it brought down production for 6 hours, so nobody's allowed to touch them. It's outdated computer software, hardware or technology, old architecture with no or very little unit tests, and developers are in general afraid to change it, and for very good reason. The second thing is that the knowledge of the system is gone. So either the developers that built the system have retired or have left the company and have left very little traces of documentation behind. And last but not least, these systems are load-bearing, as you see in the picture on the left. You can't replace them without the business collapsing because you have built a whole lot of other applications on top of them. Any of this sound familiar? Sadly, what often comes with legacy systems are legacy processes. And when processes aren't clear, legacy systems tend to amplify every dysfunction, from ambiguous requirements to late changes, to firefighting every time there is a release, to fragile environments that break every 2 weeks, and most of all, missing guardrails. It's not clear who decides, who signs off features, who owns the outcome, and in general, developers end up coding by assumption, and these projects become chaotic very, very quickly. So if it's all so hard, why don't we just rip the Band-Aid off and get rid of these systems? Well, a few reasons, in fact. First of all, as I said, they are foundational. They run your business, and there is a whole ecosystem of applications built on top of them. So you can't just replace one standalone thing. It's a whole ecosystem of applications. Secondly, the data is invaluable. For instance, in our case, for insurance, we might have decades worth of data in all databases, which are necessary for auditing, reporting, and for defining the future strategy of the company for like products or whatever. So it's very important that this data gets migrated. Third, as I said, the knowledge is gone, and this is amplified when in companies which have not been traditional software houses, many of these projects had been outsourced to contractors. So many times you get projects with missing documentation, missing specifications, and not thoroughly tested in general. For all this reason, the cost of change for the companies is terrifying. So these modernizations get delayed or rescheduled, and many times they never happen. But let's say that you have decided to modernize. This is a very brave decision. And here are some hard-won lessons that will help you avoid the worst pitfalls in that journey. First, you've got to understand that many of the people in your organization are not technical. They are mostly business people. So you have to speak their language. You might be fascinated by design patterns and cloud native, but they are fascinated by time to market and customer satisfaction. So it's very important to identify what the modernization delivers to them and communicate those values to them. This is the only way to earn their trust and convince them that this will help them. And you have to take into account that many people have built 20 years of careers based on these systems, so just calling them garbage or technical debt is not going to land very well with them. I think we need to formulate that better as technical people, say that these systems have served us well, but we now have to build the next thing in order to survive. And the last tip is to deliver fast. Start with something small that you can deliver in 2 or 3 sprints, and deliver incrementally. This way you can win people over very quickly. You can get some customer feedback from your business users quickly, and also it gives you some time to get to know the system better before attempting to change something, a component which is more difficult. And in this journey, it's very important to analyze the domain. First, you need to do some workshops, and workshops are not just meetings where people just read their email. They are really a manifestation of a culture of transparency, right? So people from the technical people, people from management and financial team all getting together and agreeing on some vision for a product for the future. As a result of the workshops, you can document the current state of your domain, imagine future states, and simplify. And one of the anti-patterns that happens in modernizations is feature parity. This is the kiss of death, I think, for modernization projects, because here is how it usually goes. Business creates a 200-page document with requirements and specification from the old system, and they give it to you and tell you, okay, so there it is, now make it faster and cheaper. But feature parity ignores a critical opportunity. So why are we doing this in the first place? Half of the features are never being used by the users, and the other half are only there because people have to work around the system because it has limitations. So a modernization is a critical opportunity to just get rid of stuff and simplify everything in order to simplify your data flows as well. So just rethink the problem instead of copy-pasting stuff. I mentioned workshops. So as we all know, because we have participated in them, workshops tend to make people feel very excited and energized for a few days. But then this momentum gets lost if nothing happens. So you need to make sure that everyone leaves the workshop with a specific action point. It might have to do with product strategy, domain exploration, system architecture, or ways of working. It doesn't matter what, you just have to leave with a roadmap of actions to be delivered at specific dates. And lastly, you need to get the business to buy in. This modernization isn't just an IT initiative, it is a business commitment. That means that the business has to maybe adjust timelines, respect the definition of done, respect the new roles that you have together defined, and incentivize legacy decommissioning, even if that means bigger risk or, I don't know, not so many releases in the first period of the modernization. Because success requires the business to adapt expectation, not just developers to code faster. Nonetheless, even if you do everything properly, chances are against you. It has been estimated that 66% of change initiatives fail, and it's only like a minority which succeed. So in order to raise your chances, there are some design patterns that can help you somehow guarantee the success. These come from the brilliant work of Rob Horn, Ian Cartwright, and Martin Fowler. And if you haven't read their series on legacy modernization, search for it and bookmark it after this talk, because it's really, really brilliant. I'll be covering only 3 patterns that actually work and are quite simple because I have limited time. So the first one is called the strangler fig application. I really like the name personally. So the strangler fig is a vine which is very common in rainforests. It grows around the host tree, gradually replacing it until the original tree is gone and only the fig is left as an echo of its shape. And I think that's a perfect metaphor for legacy modernization. So the way it works is like that you have to identify seams in your system that you can insert into it in order to split it into components. This is what the other speaker talked about, I think, about the bounded context. So you might think of it as different lines of business or different business needs. You need to identify stuff that you can somehow separate. Then you can build, for instance, new Spring Boot microservices alongside the legacy system for these components, and you need to route the new features to new services. This allows you to gradually migrate existing functionality to the new system, and this is the way that step by step the old system withers away and finally dies a natural death. The beauty in this, there is no big bang release with all the features all together. You strangle the old system gradually, learn as you go, and deliver incrementally. And when things go wrong, and they certainly will go wrong, you are rolling back just one microservice, not the whole application. Nonetheless, when incrementally replacing legacy systems with new ones, it will not always be possible to cleanly isolate the old world from the new. This is where this legacy mimic pattern comes in handy. It's your diplomatic pattern, let's say. The new system learns to speak the old system language perfectly, like a spy going deep undercover. In our example, let's say you have a monolith which talks to a very old third-party booking system. Instead of ripping this out, you just create a new booking microservice which implements the contract of the old system perfectly. So the legacy code doesn't know it's talking to something new. It's digital camouflage, basically. And that gives you the chance to update the tech stack underneath with whatever you think it's better, while keeping the contract stable. It's evolution, not revolution. Sometimes you need to do a revolutionary change, though. Revert to source is all about that. It's about cutting the ties with digital archaeology. Over the years, your legacy has probably become the integration hub with everything. So you need booking data, you go to the monolith. You need customer data, you go to the monolith. You need to know what day of the week it is, probably you go to the monolith. But here is the problem. The monolith is not the source of that data. It's just the middleman. And in our modern age of GDPR and data governance, you need to know where your data lives and who is responsible for them. So revert to source means exactly that, going directly to the source system, cutting out the middleman and simplifying your data flows. It works better when the legacy system isn't transforming the data much, just when the data is just passing through as in a very expensive, very slow cache, which in the case of legacy systems very often is the case. So I think I'm running out of time. So just to say that modernizing legacy software is not easy, but it's not impossible. Remember to listen to your people because they know more than you think. Start small and deliver fast. Use patterns like the ones we mentioned and avoid feature parity like the plague. And one last thing, don't fear legacy systems. Fear becoming one, because everything you build today might be tomorrow's legacy, and you need to build with that in mind. Thank you very much, and I will be also in Chab's booth for questions.